Hello everyone. In this lecture we will have an application of the Symmedian. This problem, we already have a proof. I will provide a second proof of this statement here. So let's recall the problem. We are given a triangle ABC. Here are the vertices of our triangle, and X is the center of spiral similarity that takes B to A and A to C. What this means, as we showed earlier, is that X is such that triangle ABX is similar to triangle ABX after rotation CXA. Okay, so that's the definition for X being the center of spiral similarity. Show that AX coincides with the Symmedian of ABC. Basically, we need to show that X is on the Symmedian line. If X such that this, then show X is an element of the Symmedian line, which starts from A and going to D, or you can say which is equal to AD. Okay, so for this proof, what I will do is I will first mark the point on the circumcircle of ABC intersection with AD as Y. So that point here, let me mark it as Y, and I will further mark the point, the midpoint of AY as X prime. So somewhere here probably. There you go. So I'll mark this point as X prime, where AX prime. So proof, let X prime such that AX prime is equal to X prime Y, where Y is in the intersection of the circumcircle and the Symmedian line. So I also marked the midpoint of BC as M and the midpoint of AC as N. And because AY is the Symmedian line, angle BAY, so angle BAY, that angle over here, I know is equal to angle MAC, and I already marked those two angles as well. In addition, you can see by that circle here, we can say that angle BYA, so namely this angle over here, let me go ahead and draw it. So this angle over here, BYA, this green angle, yep, that angle over here is equal to angle MCA, so which is this one. Obviously true because they subtend the same arc. So therefore angle BYA is equal to angle ACB or BCA, which is equal to angle MCA. Okay, good. So because of that, we can say that the triangles, and this implies that triangles ABY and triangle AMC are actually similar triangles. So ABY, you can see those three angles, and AMC, again those three angles. The remaining angles being those angles. So this one and this one are also equal. But because X prime is the midpoint of AY and N is the midpoint of AC, we can further say that this further implies that in fact ABX prime, so let me draw a new one here, let me use the blue color, ABX prime and AMN are also similar triangles. Those two triangles, let me actually highlight them so it gives us a better recognition of what's going on. So I claim that this one, ABX prime, it's similar to triangle AMN. And this is true because, as I said, X prime is the midpoint, N is the midpoint, so therefore there is no difference. Those angles are equal, so these two angles are equal obviously, and I already have those red angles are equal, so therefore this angle and this angle are also equal, so we have two similar triangles. So triangle ABX prime is similar to triangle AMN. And finally, observe the following. So we can observe that angle ABX prime is equal to angle AMN by this similarity that we just claimed. And angle AMN is simply equal to angle BAM. And let's see if you guys can see why. So why would AMN be equal to BAN? It's because the line MN, line segment MN, is parallel to line segment AB, because MN is the midline of triangle ABC, and those two angles AMN and BAM are interior opposite angles. So because they are interior opposite angles, so that those angles are equivalent. But BAM is in turn equal to angle CAX prime, CAX prime, because that's the definition of the Symmedian line. So the Symmedian line has this property. So that's very nice. But in a similar way, one can also show, similarly, you can also show that angle ACX prime is equal to angle BAX prime as well. So let me mark it with a different color. Let's just do it this way. Yep. So here we go. So angle ACX prime, so namely this angle here, is equal to BAX prime, which is just my dotted angle, right? So that dotted angle. So therefore, boom, we have the two similarities that we claimed we should be able to show. So we were able to, starting with a point x prime, which is apparently the midpoint between the segment AY, we came upon two similar triangles which create a spiral similarity that maps B to A and A to C. So therefore, we can confidently conclude that in fact the point X is nothing but X prime, and it also lies on the Symmedian, where X is on the Symmedian line, X and X prime obviously. So therefore we are actually done. So we just proved the statement that AX coincides with the Symmedian line if X is that special point, that center of spiral similarity. Hope you enjoyed the video. See you in our next lecture.